In example 3, we need to state the extrema and the intercepts for this function. Now this one looks like it could be an absolute value, so it might look like a v, but actually this one is going to look sort of like a parabola, and then we'll take a look at the graph and we'll see what the absolute value bars do. We've got a combo here of a couple functions. So what I've done is I've typed in a bunch of equations, and it happens to be this one, y sub 3, that I want, so I'll select that and deselect this one that I don't want to see. Now some of you might need to know where to get that absolute value, and some of you have the actual program where it's going to put the bars in there for you. But what you need to do is you need to go to your math button, which is down here, and then you're going to cursor one to the right to number, and it's the first one right there. So wherever you want to type that in, go ahead. So as we graph this, we're going to go zoom 6, get a nice viewing window here for this, and if we need to zoom out or zoom in, we can. So what's happening here is this function is going, it would, without the absolute value, it would come down here and then come back up, and it would have a parabola shape. The absolute value is just taking all the negative y values though and making them positive. So there's a reflection of only the bottom piece of this graph over the x-axis. The rest of it is the same. So that's what's happening with this one. Now as we take a look at the extrema, I'm going to zoom in just a little bit here for you. I hope we can get a good picture. We might have to zoom back out to get that maximum. Actually, yeah, let's do that. So I'm going to hit zoom 6 and go back to my standard, and then I'm going to go zoom box, and we'll get a better picture of what's happening here. So let's go zoom box. Remember, you're just going to go to your upper left hand side. I want to get that maximum in there, right there, the hill in the middle. So then we're going to go all the way to the right, and then down a little bit, and we're going to go to that bottom right hand corner, and that just will zoom in a little bit so you guys can see this on the video. Alright, there you go. That should be a little better for you. Okay, so we want to find this minimum here, that maximum, and this minimum. And actually at the minimum, if it hits the x-axis, that'll be our intercepts as well. So let's calculate the minimum, the 3 here. We want to go anywhere to the left, and that's -1, -2, so I'm just going to type -3. I don't want to have to cursor all the way over. -1 would be a right bound, and we could guess maybe it's close to -2 or something, I don't know. And that indeed is the minimum, and y is 0, so the minimum here is actually also an x-intercept. So let's write that down, and we'll classify it here in a second. So we've got a minimum at -2, 0, and also we have an x-intercept. We'll do intercepts here because I think there's going to be 2 of them. So that minimum is also an x-intercept at -2, 0. Now if you take a look at the graph, remember in the zoomed out picture, this graph came down here, hit this minimum, it's going to hit that maximum, hit this minimum, and go back up. Nowhere does this graph exist below this point, and so we can actually classify this as an absolute minimum. The graph only goes this low and does not, there's no point in the graph that has a minimum below that. Let's try to calculate the maximum here. So we're anywhere to the left, that's fine. We can just move over, or you can type the x value in, either one. We just have to go somewhere to the right of it and then take a guess, somewhere in the middle. So the maximum occurs at 1.5189, and there's a little e to the -6, and yours might be a little different. What this means is take this value, multiply it by 10 to the -6. So this is a very tiny number. It's close to 0, and the actual maximum will occur here at 0. There's a little bit of an error built in with your calculator for some reason. So the maximum occurs at 0.4. So let's do that maximum right here at 0.4. Now, this one, the graph has other points with higher y values, so it's just going to be a relative one. Relative maximum here. Okay, let's figure out the other minimum over there. So we'll do 1 for the left bound. We can do 3 for the right bound. We could guess at 2 if you want. And the minimum is at 2.0. So kind of to be expected, right? We've got -2 here, and probably the other one would be 2.0. So we'll write and 2.0, and actually this one's also an absolute. So we can say absolute minimums maybe at -2.0 and 2.0. The graph never goes below this point, so it's an absolute. minimum. There can be more than one. And also, that's another x-intercept. So we don't even have to do to calculate the 0 for this one, because we know that the x-intercept will occur when y is 0.